this problem, we are given a figure shown, and we are tasked to determine the vertical force P that must be applied at G to maintain the equilibrium of the linkage. Now to solve this, we disconnect each member. We have member ABC, member CE, and member DFG. We consider the free body diagram of each members. So for member A, BC, it has a force at A going downwards, that is 300 Newton, and at point B, it will induce a reaction that is both vertical and horizontal. Let's call this Bx and By. And at point C, assuming downward, for the vertical force Cy and force Cx going to the left, it will induce a reaction that is equal and opposite at point C here, is going upward, and Cx going to the right. And down here, it will induce a vertical and horizontal reaction at E, since Ey is going up. Therefore, we assume that Ey must be going down, and Ex will be going to the left. And at point E, for member DEFG, let's say it's right here, at point E, it will induce a reaction that is equal and opposite to the direction of E. So since Ex is going to the left here, therefore Ex here should be going to the right, and Ey should be going upwards. And then we have a downward force of 100 Newton at point D, and a downward force of P, which we need to solve, and a reaction at point F. Let's call this Fy and Fx. Now to solve this problem, we consider first the free body diagram of ABC. So with the exhibition moment at point B equal to 0, to solve for Cy, taking counterclockwise to be positive, we have our first equation. We have the 300 Newton force inducing a counterclockwise moment, so it's positive, times the momentum distance of 80 millimeters from the support. And then minus the for Cy, that will induce a clockwise moment of Cy times 120 millimeters, all equal to 0. And we can solve for Cy, that is equal to 300 times 80 minus Cy times 120 equal to 0. Keep solving, you get Cy equal to 200 newtons. So now we have the value for Cy. And this one is also equal to 200 newtons. Now since force P is vertical, all we need to solve is the vertical components of the force. Then we have summation of forces vertical equal to 0. We have negative 300 plus By minus Cy equal to 0. And we can solve for By, that is equal to 300 plus 200, that is 500 newtons. Now we can proceed analyzing member CE. So by summing forces vertical, we can solve this by inspection that Ey must be equal to 200 Newton to balance out the force of 200 Newton upwards, and Ey here must also be equal to 200 Newton. Now to solve for P, we take summation moment at point F equal to 0, taking counterclockwise to be positive. So we have the 100 Newton force that will induce a counterclockwise moment, so it's positive, times the momentum distance going from the support, that is 120 plus 60 millimeters equal to 180 millimeters. And then we have Ey that will induce a clockwise moment, so it's negative, times the momentum distance of 60 millimeters. And then we have force P that will induce a clockwise moment, times the momentum distance from the point F equal to 100 millimeters, equal to 0. Now we can solve for P. So we have 100 Newton times 180 millimeters minus 200 Newtons times 60 millimeters minus P times 100 millimeters equal to 0. Shift solving, we get P equal to 60 newtons. And the answer is letter C.